If at any point of time, if you have any questions for the lesson, you can just text to me into the Zoom chat and I will answer them. Okay. All right. Before I start, I would like to also just inform you, if you already haven't already known, we have actually a Telegram chat where we share cheat sheets, masterclass, webinars, and latest events, where we will feature all the free courses as well as a lot of notes and resources that we actually share into the Telegram chat. So if you have your phone with you, you can actually join us on our Telegram group, and you can actually scan the QR code to join the group as well. Okay, give you some time to do that. And those of you who needs to download the notes or print it out, you can do so as well. Right? Okay, so for today's session, we'll be covering atomic structure, which is the first topic, the first key topic that we'll be studying in secondary 3 chemistry. So if you have the notes with you, can you please give me a thumbs up on the Zoom so I can see you? Can I? Okay, then let me start off with the atomic structure. Right, so you realize that in lower secondary, you learn some schools, they teach chemistry first, physics, then bio. Then some schools, they teach combined sciences as well. So they actually teach all 3 sciences together, blended as well. So when you come to upper sec, you realize that you either have to take triple science or either 2 of the sciences, with chemistry being the compulsory science. So at this point of time, right, you realize that chemistry has a lot of importance, even though you may not like it at first, but what our main aim here is to help you to instill a sense of liking towards the subject as well. Okay, so you can try and recall what you have learned previously, but actually it's not very necessary. You just come in with an open mind, and then we will learn together for this topic of atomic structure. Okay, so this topic is actually sometimes a little bit challenging for first timer. So I would like everyone to actually pay close attention, and if you have any questions, please feel free to ask during the session as well. Okay, so if everyone is good, then can you please open your notes to page number 2 as well? All right. Okay, let's look at the first concept for atomic structure, right? So for atomic structure, you have actually learned this way back in primary school, right? Primary 5 and primary 6. You have learned that atoms are the basic building blocks of life, right? So nothing can come about without atoms. And the very topic that we actually learned in our entire life, right, is actually matter. So you remember in primary 5, you realize that there's this topic on matter that you have actually learned. And this topic on matter actually tells you that things that occupy space, we consider them to actually be matter. And what is the guiding principle behind matter is atoms. Okay, so it is precisely because of atoms that is the reason why we actually come up with this term over here called matter. These atoms are the ones that actually make up the entire matter that occupies space. Now, what actually makes up an atom and what exists within an atom itself, right? So let's explore this together as we explore into the world of atomic structure, right? So an atom itself, okay, is basically, once again, I re-emphasize this, is the simplest building block of life. And within each atom, right, some people may think, isn't all atoms exactly the same? I have one atom here, one atom there, all the atoms are exactly the same, right? The whole world only have one type of atom, which is the ones that make up every single thing. Now, I want to give you a very special example. Now, if I have a water bottle over here, as you can see, and this water bottle is made of plastic. Now, plastic is actually a type of chemicals that actually has been solidified as well. And within the plastic itself, you will realize that if you zoom in many times, you realize that the plastic looks something similar to this, okay? You don't need to copy this down, but you can actually just take a look at what I'm drawing on the screen itself. So basically, it's actually a lot of small particles that are linked together, and that is the reason why there is a whole network, and it makes it look like a bottle or a solid object by itself. Okay, and this applies to many other things as well. For example, you go out, you wear your headphones. For example, your the computer that you're sitting in front of as well. Okay, these are all made out of a lot of atoms, and one atom is really very small. Okay, now let's look at the model of an atom on page number 2 over here. Now, within the model of an atom, right, okay, I'm just going to introduce to you the Rutherford model. Now, the name of the model is not important because it is just the name of the scientist who actually invented the model itself. What is important is actually the understanding and the idea behind the model. Now, in an atom itself, right, we have understand from primary school that each atom has different components to it. So you understand in lower secondary as well that you have actually the nucleus and you have the electron shell. So I'm going to re-emphasize this idea again for you over here. The nucleus is at the center of the atom. Okay, so in the center of the atom, right, this over here is what we know as the nucleus. Okay, it's basically a small a place over here whereby many particles can be found into it. Right, so this is the nucleus, and the nucleus is found in the center of the atom. And okay, what is in the nucleus is basically these two things. Okay, you may want to copy this down as well. Okay, so for firstly, we have neutrons, which is inside the nucleus. Okay, and proton is also inside the nucleus. So these are the two subatomic particles that are inside the nucleus. Okay, so this over here, this entire thing over here is known as the atom. And whatever that is found inside the atom, what do we call this? We call them subatomic particles. Okay, understand this with me, subatomic particles. Now, neutron is a subatomic particle. Proton is also a subatomic particle. Okay, they are positively charged due to the proton. Okay, so you can see over here, neutron is neutral, they have no charge, but proton is positive charge. Therefore, this whole nucleus become positive. Okay. Next, we look at the second part of the atom. So basically, there are two parts. First part is the nucleus. Second part is the shell. Okay. So we look at the shell. Now, the shell of the atom is basically surrounding the nucleus. Okay. So at the surrounding of the nucleus, you will realize that there is this shell that is around the nucleus, and there are electrons that are surrounding it. Okay, electrons that are surrounding it. And it turns out electrons move very fast. They move nearly at the speed of light, right? So what happened is that the protons is in the nucleus, it is positive charge. We see that there are electrons as well. And the electron is actually moving outside of the nucleus, okay, in the shell. So the electron is inside the shell and it starts moving around, and it is actually negative charge. Now, why is it negative? You must understand this is positive. For my electrons to want to stay inside the shell, it needs to be attracted towards the nucleus. Understand? So I have the electrons over here. So it needs to have a certain attraction with the nucleus, okay, for it to actually continue its orbit within the electron shell. So that's the reason why your proton is positive and your electron is negative. Now let's fill in the blanks at the bottom and let's consolidate what we have learned so far. Now, if you feel that I'm going too fast, okay, please let me know. Or if I'm going too slow, or if you want me to re-explain a certain concept, you can let me know as well in the chat. Okay. I know some of you are shy. You can actually direct message to me as well. Don't need to direct message to everybody. Okay. Now, let's look at the key points over here. Okay, we have learned that protons and neutrons, they are actually found in the nucleus. And they have a very special name for this, and they are called the nucleons. Okay, so write this down with me. They are called the nucleons because they are found in the nucleus. Now, we have also learned that there is the nucleus here, and what is around the nucleus are electrons. So the nucleus is surrounded by electrons. Okay, so they are surrounded by electrons, and the electrons are in constant motion around the nucleus. Now, these electrons, right, it turns out they are actually found in the electron shell. So they don't go anywhere, but they are found inside the shell. Okay. Now, you understand with me that just now I mentioned that electrons move at the speed of light. Move at the speed of light means very fast. The speed of light is around 10 to the power of 8 meters per second. which means that it's very, very fast. So if an electron is moving at this speed, do you expect it to be very big or very small? It must be very, very small, and it must be very, very light as well. Okay, so therefore, the mass of the electron is negligible compared to the mass of the protons and the neutrons. What does this mean? It just means that protons and neutrons, they are heavy, but electron is very, very light. Can I? Okay, give you some time to copy this and digest this before we move on to the next page. Okay, meanwhile, any question? Okay, let me know if you have any questions, okay? Okay, I'm going to go to the next page already. Okay, and let's go on to page number 3. Now, next up, I want to introduce the idea of valency. Now, if I, follow me, find a blank space, let's draw this together. Now, first off, I'm going to draw the nucleus of an atom. Okay, I draw the nucleus first. Next, I want you to follow me closely. Let's draw in 2 electron shells. Okay, this is the shell, the first shell. And let's draw in another shell as well. So sorry, the shell is a little bit more shaped like an oval. Give me a while. Oops. Okay. Right. So you can see over here that we have 2 electron shells. The electron shell are in blue color. Right. So blue color, these are electron shell. The one in black, this is your nucleus. Now, if this atom, I tell you that this atom, they have 2 electron shells. So this is shell number 1 and this is shell number 2. Now, there is a special name for this particular shell number 2. Since this shell over here is the furthest one away from the nucleus, we give it a special name. It is called the valence electron shell. Valence electron shell. Okay, and in this particular shell, there exists valence electron. So if I got electron inside here, okay, 1 electron, 2 electron, maybe I got another electrons here. These electrons over here, the black color ones, they are known as the valence electrons because they are found in the valence electron shell. Okay, so let's fill up the blanks over here. Now we know that the valence electrons are the outermost electrons of an atom. Okay, I want to re-emphasize this idea that they are located the furthest from the nucleus. So you see over here, the nucleus is here. The electron is actually all the way outside over here. They are very, very far. They are the furthest electrons away from the nucleus. Is this okay, everyone? If you're following, can you please give me a thumbs up? Okay, thank you, Phoenix. Thank you, Lily, and thank you, guests as well. Okay, let's go on to charges. Okay, so just now we talked about the particles, the different particles that are inside an atom, and we're gonna now deal with the technical parts of each of these particles. Okay. Now I want you to understand this with me. An atom, okay, an atom is electrically neutral. Okay, what does this mean? An atom is electrically neutral. This means that it does not have any charge. Okay, no charge, right? So they have no charge, which means that the net charge is 0. This is because the number of proton equals to the number of electron. Okay, remember just now what they are saying is that proton is positive, electron is negative. So if I got 1 proton, I got 1 electron, total charge is 1 plus minus 1 equals to 0. Okay, let's deal with them individually now. Okay, so proton, The symbol, okay, scientists have come up with a symbol for proton, neutron, and electron because they don't want to spell out the whole name. They want to just write very quickly, right? So what is the symbol? Just copy down with me now. Very simple. It's just P, N, and E. Very lame, right? Nothing much one, right? So let's talk about the charge on the protons, neutron, and electron respectively. Now, the proton itself, as the name suggests, P stands for positive. Okay, charge therefore is going to be +1. Now we talk about neutron. Neutron is neutral. Okay, therefore the charge on the neutron is 0, or sometimes we call it neutral. Now, what about the charge of an electron? Now remember electricity, okay, it is negative. Therefore, the charge on the electron is -1. Okay, so the charges, you must be very clear. Proton is positive, neutron has no charge, and electron has negative charge. Hannah, what about the relative mass just now? I'm going to write down the relative mass. Okay, just copy down first. I'm going to talk to you about it later. Okay, write down the relative mass first. Now, you can see over here that the relative mass for proton and neutron is 1 and 1. So this means that proton mass is the same as neutron mass. But the thing is, you realize over here that electron mass is 1/1840. Now, what does this value mean? Now, this means that I need 1,840 electron to have the same mass of 1 neutron. This means that the electron is very light, right? Very light. So small until I don't even, it's like a very, very small fraction, right? So therefore, scientists have thought about it. They have approximated this to 0. So I just say, oh, electron don't have any mass. Okay, it is just something that is very, very light. Okay, is that okay, everybody? All right. So if you have understand this, then you can go on to the next part with me. Okay, so I'll give you some time to copy this down first. Let's go on to the next part in around maybe 30 seconds. Okay, let's move on to concept number 2. Now, concept number 2 is one that sometimes students will get confused because they haven't learned this properly in lower secondary. When they come to upper secondary, they realize that it's sometimes a little bit difficult to understand, right? Because they realize that last time when I look at the periodic table in secondary 2, oh, it's just a table with a lot of values, but I don't really know how to use it. So in this particular segment over here, I will teach you how to master using the periodic table. Okay, I trust that many of you over here are secondary 2 students going to Sec 3 next year. So it's a very good knowledge for you to have if you know how to use the periodic table before other people, right? So when the exam comes, just take out the periodic table, apply the stuff that I tell you, you can actually score well. Okay, right. So let's talk about elements. Now, what is the element? Element actually is the individual things that actually make up one particular product. So let's talk about maybe I have a pen over here. Okay, let's try and get the pen over here. Okay, I have a pen over here. Now the tip of the pen is made up of probably maybe iron. Let's say it's made of iron. Now iron is an element, okay, and it has its own structure of atoms. This means that, okay, within the atom, how many protons I have, how many neutrons I have, how many electrons I have is entirely dependent on what type of material it is. Okay? Now, I want to give you a very, very good example. Let's talk about sodium. If you go to your periodic table, okay, you can find this on page number 6 of the notes. Okay, so this is the element sodium. Now, in this element, you will see something. You will see that there's a number on top and there's a number below. Now, in the periodic table, you will realize that the number is actually written like this, okay? So it's like that, and 23 at the bottom. But this is the conventional way of writing. This is the periodic table way of writing, okay? So periodic table always, you can see that the bigger number is below, smaller number is on top. Okay, so I'm going to erase this one first. Let's talk about the convention way of writing. Now, at the top over here, we are talking about the nucleon number. Now, what is the nucleon number and what is the proton number? Now, at this point of time, I want you to understand with me, right? Just now we talk about nucleons. Now, nucleons is made of what? Nucleons is made of protons plus neutrons. Okay, protons being the positive ones, neutrons being those that are neutral. So this nucleon number is the total number of proton plus neutron. Now, proton number, what about it? Proton number is basically the number of protons only. Okay, so always you see nucleon number is the bigger number, proton number is the smaller number. Can so far? All right, let's look at proton number first. Okay, so proton number is basically talking about the number of protons in an atom. Okay, or the number of electron in an electrically neutral atoms. Now, what is meant by electrically neutral atoms? It basically means that the net charge is equals to 0. Okay, means that the number of positive charge equal to the number of negative charge, means that number of protons equals to number of electron. Can? So in this box over here, can you fill in for me the number of protons equals to the number of electrons for electrically neutral atom? Okay, so this is your formula number 1 that you need to remember. Okay, not really remember, but you just need to make sure that you know this at the tip of your fingers, because when we talk about protons and electrons, for an atom, the number of proton is equal to the number of electron. Now, then we move on to the nucleon number. Okay, the nucleon number. Now, before that, let's take a look at this atom of sodium over here. Now, the proton number is 11. This one over here is the proton number. And the number on top is the nucleon number. Okay, once again, nucleon number is proton plus neutron. Proton number is just the proton itself. So if I tell you a question, if I ask you a question, how many electrons are there in the atom of sodium? So can somebody tell me, okay, how many molecules of electron there are, how many electrons there are in one atom of sodium? Can someone type into the chat? Okay, very good. Okay, 11, because atom of sodium is electrically neutral and therefore there is 11 electrons in an atom of sodium. Okay, so well done to Guest and Lily as well. Okay, now then we move on to nucleon number. This is the next concept that some students may actually find it a little bit difficult to understand, but let's just do it anyway. Now, we remember just now that the mass of proton and neutrons, right, they are very heavy, right? Remember, just go back to on top. Now, neutron and proton, they are heavy. You'll see the mass is 1 and 1. But you can see over here, the electron is very light because you see the mass of electron is 0. So that's why when we talk about the mass of an atom, okay, the mass of an atom, it is basically correspond to the nucleon number. Okay, so nucleon number, sometimes we call it the mass number as well. Okay. Now, don't bother about the Z and the A are not really very important. You just need to know which one is the nucleon number, which one is the proton number. Now, for the nucleon number, okay, let's fill it up together. It's the total number of protons in the atom plus the total number of neutrons in the atom as well. So whatever that is inside the nucleus, I count the number inside the nucleus, then I will say that it is the nucleon number. Or how heavy is it? What is the mass number? Okay. At this point, I also want to tell you a formula to calculate the number of neutrons. Number of neutrons. So if I talk about the number of neutron, let's write this formula on the top. Number of neutron. Okay. Now, how do we calculate number of neutrons? Just now we say that this is P. This is P plus N. Anybody very good in math over here can tell me very simply the neutron number will be equal to the nucleon number, okay, minus away the proton number. Okay, this will give me the number of neutrons. Okay, don't get confused between nucleon and neutron. They are different things. Nucleon is basically what is inside the nucleus, proton and neutron. Neutron is the particle itself. They only have zero charge. Okay, so you understand this with me first. Now, therefore, it's very useful for you to understand this idea because many students are in the middle of Sec 3. They will tell me, oh, I don't know how to find the number of how many subatomic particles there are. Or, I see this question already. I'm very confused by what they are trying to say. Nucleon, neutrons. You must get this idea correct first, okay? So nucleons are proton plus neutrons. Okay, so you can take a moment to copy this down as well before let's move on to page number 4. Okay, before that, any questions that you may have? Okay, if no questions, I'll move on already. Okay, let's go to page number 4. Okay, so page number 4, there is some question for you to do. Okay, so for page number 4, you can see that we have exercise number 1, exercise number 2, and exercise number 3. Let's look at exercise number 1 first, okay? So give you some time to take a look at this question, and I will go through this question in a while, okay? So if you need help, you can look up to the screen and actually take a look at what hints that I have written for you. If you're okay, then you just do it yourself, okay? Try yourself. Okay, let's look at the question together. Now, in this question, we are given that proton number is 4. So P equals to 4. Nucleon number equals to 9. So P plus N, where the P stands for proton, N stands for neutrons, equals to 9. And we are asked to find out what is the number of proton, neutron, electron in an atom. So whenever we see the word atom, the number of proton must automatically equals to the number of electron. Okay, so proton very easy. They already give you the answer. P equals to 4. And very simple. I just need to take this value over here, which is 9 neutron number, minus away proton number. It will give you 5. And E equals to P because we have already stated over here that the formula says that protons equals to electron for an atom. Therefore, it is also going to have 4 electrons. Okay, easy, right? So question number 1 is just for you to take a look at, try and understand the concept a little bit better before we start on to the more challenging question in exercise number 3. So let's look at 2 first before we go to 3. Okay, 2 is a very good consolidation. So I put this picture in for you to actually consolidate all your concept as well. Okay, so try your best to fill in all the blanks. If you need the answer, just look up and the answer will be there. Okay, so you can see over here that in this particular figure over here, you can see that there's a nucleus. Nucleus is over here. In the nucleus, there's protons and neutrons as mentioned. And you can see that outside of the nucleus, there are different shells, right? Different shells. So inside the shell that is inside there is known as the electron shell. What about the shells that are on the outside? The outside is known as the valence shell, right? Just now we say that the outermost shell is known as the valence shell. And the electron that is found in the outermost shell is known as the valence electron. Is that okay, everybody? So valence electron and valence shell. Can I? Okay. Okay. If you have no questions, then we move on to the next part already. This one should be quite simple for all of you. Okay, I'll go to question number 3. Now, question number 3 is a little bit more challenging, right? So we are asked to find out the number of protons, electrons, neutrons in the following elements. So we got A, B, and C, and then let's try and do this in maybe 3 minutes. I think we can do it in 3 minutes. Shall we try? Okay, so let's do this in 3 minutes. Okay, you can look up if you are done. You can see the answers. If you have any questions, you can actually type to me in the chats. Please don't feel shy to ask, okay? Everybody is here to learn, especially when most of you are actually going to Sec 3 next year. You need to have a positive learning attitude where you actually try and ask the question yourself, okay? Don't try and wait for other people to ask. And sometimes it will take quite long for your question to be answered if that's the case. Okay, so time already. Let's look at the question itself. We are asked to find out what is the proton, neutron, electron number. Very simple question. How do we do that? We need to first understand that the number on top, which is the bigger number, belongs to the nucleon number. Nucleon number, once again, what does it consist of? Proton plus neutron. What about the bottom number? Number of protons. Therefore, okay, for me to find the number of neutrons, I will take the top number minus away the bottom number to give me the number of neutrons. For electrons wise, how do I get the number? Very simple. Since it is an atom, electrically neutral, therefore, the number of protons must be equals to the number of electrons. And so far, everybody? If you're okay, can you please give me a thumbs up? If you're not okay, give me a thumbs down, okay? Okay, very good. So most of you are fine. I will move on to the next page already. Okay, so if everybody is good, can you go on to page number 5 with me? Let's look at concept number 3, which is about electron arrangement. Now, what is electron arrangement? This concept is very like a bit chim, right? A bit chim for us to understand. But let's try and simplify this until it is very easy for us to understand. Now, I give you an example, right? Okay, I give you an example. Let's find an empty space. Now, I want to give you a very easy example for you to understand this. Now, there is this particular thing that I want you to remember. Now, if let's say I'm talking about electrons, okay? I'm talking about electrons. Okay, find an empty space with me. You can write this down. Now, it looks something like a car park. Okay, it looks something like a car park. Now, I tell you a very simple question, simple example. Now, the nucleus is the center of the car park. Now, around the car park, right, there are different levels, right? So we have level number 1, we have level number 2, and we have level number 3. Okay, you can draw it in a full circle. Sorry, I have no space, so let me draw it in an oval shape. Okay, it's supposed to be a circle. Now, in these few levels, right, there are so many levels. I can extend to level 10, level 11, but I'm just drawing the first 3 levels for you, okay? So how does this actually work? So when the electron come in, okay, they want to park themselves, okay? So electron are the cars, they want to park themselves in the car park lots, right? So there's this principle that scientists have found out, okay, that is actually very interesting for us to learn as well. Now, in the first particular electron shell or the first level, this level is a very small level. You can see the area of the level is so small only. The next one is quite big, right? So first level is actually quite small, right? So how many car park lot there are? There are only 2 car park lot. Therefore, I can only have 2 electrons in the first level. Okay, or what we call this, the innermost electron shell, the one that is closest to the nucleus. Okay, so this one, the first electron shell has maximum 2 electron space. Can Next, we will look at the next car park lot, which is on level number 2. Okay, so this level 1, next one is level number 2. Now, in level number 2, right, the space is a little bit bigger. So in this car park, right, there are actually 8 car park lots. Okay, 8 car park lots. Now, I want to show you how the car park lots are arranged. They are not like that. Don't copy this down. They're not 1, 2, 3, 4. They're not like that. Okay, they're actually arranged in a very, very special way. Okay, I'll tell you why. Now imagine that you go into a car park. I give you an example. Okay, so I have a box over here to show you an example. Now, if I have a box over here that the car is parking, if all the cars park on one side of the car park, wouldn't the box topple over? Similarly, if let's say all the car park here, they will topple to the front and topple to the side as well. Therefore, the electrons are very smart. They actually arrange themselves in a way that they maximize stability. Right, let's write this down. Electrons always arrange themselves in a way that they maximize stability. Okay, they want to be stable. They don't want to run about. Okay. Now, how do I achieve this? Interestingly, okay, what scientists observed was that they actually arrange themselves, look something like this. 1, 2, 3, 4. This is the way that they arrange the electron first. Now, in the second car park, right, or the level number 2 over here, right, now you can see that there are 4 cars inside already. There are 4 electrons already. Now, it turns out, right, this level of the car park can actually hold up to 8 electrons. So you see here, 1, 2, 3, 4, they are very far apart. They can maximize stability already. Now, it turns out when more electrons come in, they want to park at level 2, right? How can they park themselves? They actually park themselves in this pattern, right? They park 1, 2, 3, 4. Okay. They park themselves together. So they park 1, 2, 3, 4. They have 4 couples, for example. Okay. So in the second electron shell, they have a maximum of 8 electrons. Okay. They have a maximum of 8 electrons. So they are arranged in this particular format, whereby we have 2 electrons that are together with each other, okay, around the whole level. So they are spaced out maximum like this. Okay. And on the third layer is the same thing as the second layer. The maximum the third layer can hold is 8 electrons as well. So it looks something like this. Okay, the blue ones are electrons, by the way. So these are the electrons. So the third layer also have a maximum of 8 electrons. Okay, so as the layer get bigger and bigger, they can hold more and more electrons. But for O-level syllabus, okay, you only learn up to level number 3. So maximum is 8 electrons here, no more. Okay, so level 2 and level 3 are exactly the same. They can only hold up to 8 electrons, okay? So I will give this example always to my students when they are doing this atomic structure. Right? I hope this help you to understand how electrons arrange themselves. Okay. So always the main aim is for you to maximize stability. All right, let's come back to the page itself. Okay, so whatever that I've drew over here is nicely summarized for you in this picture over here. All right, so you can see that we are learning up to the first 20 elements, maximum 2 electron, 8 electron, 8 electron. The rest, we don't care. All right, now some of the technical detail I'm going to go through with you. In the shell, right, the first criteria is the shell is numbered 1, 2, and 3. So we got 1, 2, 3, 4 as follows. So level 1, level 2, level 3, level 4, right? So your car park got different stories. Okay, and it goes outwards from the nucleus. So nucleus is always in the center, and it is just going to go outwards. Okay. The inner shell is filled up first. Now, why is that so? Okay, you imagine now you go to a shopping center, right? The entrance is at level 1. So everybody want to park their car at level 1 first because they can just walk to the shopping center. Then if I park at level 2, I need to climb down the stair that I can go to the shopping center, right? So everyone want to park at the lower level first before they park at the higher level. Okay. Then next in criteria number 3, each shell can only hold up to a maximum number of electrons. As mentioned, level 1 got 2 electrons, level 2 got 8 electron space, and level 3 got 8 electron space as well. Okay, so these are the 3 criteria that you need to know whenever we are looking at electron arrangement. Okay, so how do I apply this? How do I apply this idea? Okay, let's zoom in a little bit. Now I tell you, right, that this element has 7 electrons. Okay, I tell you this element have 7 electrons. Now, can everyone draw onto the diagram with me how the electrons arrange themselves? Okay, try now. If I have 7 electrons, how do they arrange themselves? Yeah, so always electron is actually written as a circle. So sorry, I have a chat. 2 in first and 5 in second. Very good. Okay, so we have 2 electrons in the first shell and then 5 electrons in the second shell. Okay, but how to draw? How to draw? Let's look carefully. Now, in the first shell, the electron want to space themselves as far as possible, or somebody will, sometimes will draw like that. Can also. Okay. Now, in the next shell, right, we always follow this idea. Here, I got 2 electrons already. The next one, I have 5 electrons left to arrange, right? So I have gonna have 1, 2, 3, 4. And where's the 5th electron gonna go? Okay, it's just going to pair up with one of the electron that's already there. So that is how the 5th electron is going to arrange themselves. Okay, so this is the arrangement of electron. If let's say that this element have 7 electrons. Okay. Now I want to extend this idea a little bit further. Okay. Now I don't want to tell you about I don't tell you about how many electrons there are already. I'm going to write this element down for you and draw out the electronic configuration for this element. Okay, find an empty space with me. Okay, I want you to draw out the electronic structures of this element. So first you must draw, okay, the first shell, the label sodium. Okay. Okay, 3 shells for you. Okay, try your best. Now, this is the proton number once again. This is the nucleon number. Okay, so what information do you need? I have provided everything for you here. You can try and draw out the electronic structure. Okay, if some of you need the hints, I will write the hint for you. Okay, somebody asked a question. Now, why is it that we only have electronic configuration for electron? Why don't have electronic configuration for proton and nucleon, right? Or neutron, right? Because, right, the neutron is all inside the nucleus already. The proton and neutron are all inside the nucleus. They are together, they are squished together. They have no arrangement. But electrons, they are actually orbiting around the atom. Therefore, they are actually having a particular arrangement that you see over here. Okay. So good question. Now let's draw in. Okay, first shell, I can have 2 electrons. Second shell, I can have how many? 8 electrons, right? So I put in 1, 2, 3, 4, 5, 6, 7, 8. And now how many electrons do I have? So I have 2 already, I have 8 already. I need 1 more, right? So I'm going to draw in 1 more shell. Okay, 1 more shell, and I'm going to put in 1 electron there. Is that okay, everybody? So this is how, okay, your sodium atom actually looks like. Okay, if all of us are good with this, then we're gonna move on to the next part already. Can you use X to represent electron instead of circle? Can, of course. Okay. For simplicity's sake, yes, you can use X to represent that, or you can use the dot as well. Okay. Yeah, some tutors prefer to use X, some people prefer to use dot. Okay. Personal preference, both will be accepted as well. Okay, I prefer to use dot because it's neater. Yeah, but both also can. So if let's say you draw like this, okay, you draw like this, also okay. Okay, some school will teach just use X, some school will teach use the dot as well. Both are okay. Now let's look at exercise 4 already. Okay, let's look at exercise 4 now. Now, we are asked to draw the full electronic configuration for atom of oxygen and atom for aluminum. Okay, now I give you some time. I try to actually draw this out. I will actually fish for the details for you. Okay, you can see on the next page, on page number 6, the details are actually here. So I highlight the elements for you on page number 6. Okay, where is my AL? Okay, so oxygen and aluminum are there. Okay, use this information to draw out the electronic configuration. Shall we do that? Okay, if you're all good, you can just look up and take a look at the electronic configuration and cross-check with yourself, see whether it is correct. Okay, some students may ask, right? For aluminum, okay, aluminum, if you draw the electron like this, is it okay? In the valence shell, if you draw it like this, is it okay? Yes, it is okay as well. Okay, so if you want to space it out, for example, if you want to draw it like this, also okay. Okay, so you must count the number of electrons, 1, 2, 3, 4, 5, 6, 7, 8, match with the number of protons. Number of proton over here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 electron match with number of protons. Okay. Okay, so if some of you are still trying out, okay, don't worry, take your time. You must always remember, you must always label the element in the middle over here. So for example, aluminum, then you just write Al in the center. If it's oxygen, then you just write O in the center. Okay. All right, any question, anyone? Okay, so let me just go through something that is a little bit extra, but you must know as well. Huh? Now, this over here and this over here are what we call the drawing of the full electronic configuration. Okay, now drawing of the full electronic configuration basically means that I'm trying to display out how the electrons are arranged in the atom. Okay, what about if the question says, I don't want you to draw, but I want you to write out the full electronic configuration of the element of oxygen or the element of aluminum. How do you do that? Basically, how we actually do that, the notation looks something like this. So how do we do that? We will always write a number, followed by a number, followed by a number. So number, comma, follow number, comma, follow number. Okay. Now, what is this basically talking about? Okay, don't copy this down first. It's basically asking us to write out how many electrons there are in each shell. So for example, let me use oxygen as an example. Okay. So for oxygen, you know that there are 2 electrons in the first shell. So I put 2, comma. The second shell got how many electrons? Got 6 electrons, right? So 2, 6. There are no other shells, okay? There are no other. Third shell got no electron, fourth shell got no electron, okay? Don't bother about it. So this will be the written configuration. Now, I wanted to try this for aluminum, and you must tell me what is the electronic configuration, the written one, okay, for aluminum. Okay, let's try this. Okay, so for those of you who got 283, excellent. 2,8,3. Okay. Now, this is an excellent way for you to double check your answer as well. Because you can see over here that the written configuration is very easy, okay, for you to actually, it's very easy for you to actually see, okay, the electronic configuration or the number of electron total, whether you draw it correctly or not. 2 plus 6 give you 8. Right? 2 plus 8 plus 3 give you 13. Very easy for you to check. Okay, I have a question here. Can I use dots to represent the comma? Right. So for simplicity's sake, right? Normally in textbook and normally for O level, they will expect you to use comma for the things for the electronic configuration notation. But if you write dot as well, okay, so those of you who never write this before, please don't write this. But some school or some of the students, they may prefer to write it like this. Okay, it is sometimes school don't accept it, but for Cambridge in O level, they will accept. Okay, so no worries, but this one should be the preferred option. Okay, it's very clear to me that, okay, the first one got 2, the second one got 8, the one got 3. Okay, so it's just a notation difference, but no worries about that, right? So you just write the number of electron in the first shell. Okay, so I got 2 electron. Once again, if for those of you who are not really following, let's look at this together. 2 electron in the first shell, 8 electron in the second shell, and 3 electron in the third shell. Okay. Okay, so this is what we call the written notation for electronic configuration. So you realize that for this chapter, it's a lot of understanding of different elements, different atoms, different type of species, different type of subatomic particles as well. Now, some students always tell me, right? Some students always tell me, oh, Mr. Ko, chemistry is only memorizing. Chemistry is only memorizing, cannot understand one. Right, so you must be able to appreciate the idea behind each concept. Okay, you must appreciate the beauty behind every chapter. You must appreciate why does certain things perform this way? Why is it that the electrons are going to stay together like this? Why is it that different elements have different type of configuration? Okay, so don't just memorize. You memorize. Most of the time, 95% of people who memorize, they don't really do very well. Right? So if you're all good with exercise number 4, can we move on to the next page? Okay, now let's look at the next concept number 4, which is talking about atoms and ions, right? So ions are a little bit less familiar to you maybe, because some of you maybe haven't really got exposed yourself to this particular idea yet. So what I want to do, right, is for you to actually be able to understand with me how atoms actually transform themselves to form ions. Now, atoms very simply refer to uncharged species or uncharged particles, whilst ions, they refer to things that are charged. Means that they are positive maybe, they got negative maybe. Okay, so uncharged means the number of positive and number of negative, they cancel each other out. But charge means maybe the positive got more or the negative got more. Okay. Okay, so let's look at the periodic table first. Just now I was highlighting this. I'm going to erase this already. Yeah. Okay. Now, we always look at the periodic table like this. Okay, so we always look at the vertical and the horizontal. Now, the vertical is known as the group. So I got group number 1, group number 2, group number 3, 4, 5, 6, 7, and 0. Okay, not 8, but 0. I'm going to tell you why later. Now, group 1, 2, 3, 4, 5, 6, 7, they are all written in Roman numeral because they write it last time, right? But they give us the periodic table now, so we must accept that it is in Roman numeral. But the thing is, it doesn't really matter if you don't understand, just write 1, 2, 3, 4, 5, 6, 7, and 0. Very simple. Okay. Now, you can see that there are a lot of elements over here that some of you may be familiar with, some of you may not be familiar with. So you can see, for example, like oxygen, or very simple, this one is in the air, I know, right? Aluminum, of course, I know aluminum foil that are used in baking. Okay, for example, stuff like copper wire, okay, you also know. But some stuff like, let's talk about vanadium, or let's talk about chromium. All this stuff, we don't really touch it that much, right? So that is the beauty of the periodic table. It exposes us to different type of chemicals or elements that we are actually not very familiar with in the real life. Right? So let's talk about the periodic table, how to read the periodic table. Now, if I tell you that I want to find an element that is in group number 1, then where will my eyes go? Very simple. I say group number 1, right? Let's look at group number 1, like that. Okay, so this over here is group number 1. Let's say I want to look at group number 7. Then I come here and I look at these elements. Okay. Okay, so for O level, you just need to learn the first 20 elements, which is all the way until here. These are all the elements that you will learn in your syllabus, nothing else. Okay, quite simple, but we'll get to that later. You see that there's a lot, right? But it's okay. Okay, let's slowly conquer each one at one point of time. Okay, so let's go to the next part first. Now, group 0 is very special. Group 0 is very special. Let me talk about group 0. Now, group 0, right, the special part about it is because it is very good. Okay, G-O-O-D, very good. Now, why is that so? Now, because, right, okay, scientists have actually found that all the elements in group 0, all these elements that they try and tested, okay, they realized that all these elements, they are unreactive. Okay, all these elements are unreactive. That's why they all push it to the right of the table, push it to the right of the periodic table. Unreactive. I don't want to deal with it. I put group 0. Okay, so group 0, everything inside here is also known as a noble gas element. Okay, noble gas element. This is a new term that you must learn. Noble gas element means it is in group 0. Can so group number 0, you got helium, neon, argon, krypton, etc. all the way down, right? Now, why they call noble gas? Noble gas because it's very good, very stable. Very stable, right? Very stable. Just like I say already, why is it very stable? Because, okay, give you an example again. I got 2 cars here, I got 2 cars here, 2 cars here, and 2 cars here. 8 cars in total. This thing is not going to topple. But if I got 2 cars here, no cars everywhere else, then you see it's going to topple, right? So let's look at the electronic configuration of noble gas element first. Okay, find an empty space, maybe on top over here. Okay, I'm going to erase this. Okay, so let's draw out the electronic configurations of, for example, helium. Okay, can we draw out the electronic configuration of helium? Helium is has 2 electrons, so therefore it is going to look something like this only. 1 and 2. That's all. Finish. Now, if you talk about neon, on the other hand, neon has 10 electrons, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, what do you notice about this? You realize that level number 1 and level number 2, they are both fully occupied. They are all fully occupied, right? So there's no empty car park lot. This means that there is many electrons that are already inside the car park lot. The car park is full, and therefore it is very stable. Okay, can get me on this first, So we have all the cars in the car park, okay, all already inside there. And what do we call this arrangement over here? We call it the complete octet electronic configuration or electronic structure. Okay, complete octet, right? So why is it octet? Because I got 8 electrons, okay? 8 electrons, therefore octet configuration. Okay, it's a complete configuration already. Now, let's move on to the next part, okay, which is to write out what is to specify out what is the gases, the configuration of the gases, as well as the description of why a noble gas is good. Okay, so noble gas, follow with me, is very stable. Okay, atoms of other elements can obtain the stability, okay, by what? They can either gain electron to have this stability, or they can lose electron to get this stability. What do I mean by this? Okay, let's come back to this example. Now you can see neon over here, right? Okay, it looks something like this. I'm going to just box up neon first. It's a little bit messy. I'm going to erase some of the stuff. Okay, let me box up neon first. Okay, follow me very closely. Okay, magic is about to happen. Now let's look at fluorine. Fluorine has 9 electrons, right? So how does an element look like? It looks something like this. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is how the element of fluorine look like, right? So what do you notice about this? In the valence shell, remember valence is what? Outermost shell, right? In the valence shell, what happens is that there is a lack of 1 electron to fill up the empty car park lot. You see over here, just now over here that there's 1 empty car park lot here. No electron here. So what can fluorine do? Because this one over here, not stable. But this one over here, on the other hand, very stable, right? So what can this fluorine do? Very simple. I go somewhere else, I find 1 electron. I find 1 electron. I'm going to bring the electron to fill up the car park lot. Okay? Then this will give me extra stability. Okay, extra stability. Then this one, instead of this already, it is going to be, okay, extra stable. Now, then we move down to the description. Okay, so this particular phenomenon over here is called gaining an electron. We can also do the same thing by losing, okay, the electron as well. Now, what happens then if I gain 1 extra electron? Let's go back to the example of fluorine. Now, fluorine, right? Originally, let's look back at the electronic structures over here. Originally, fluorine has 9 proton and 9 electron, right? Now, what happens if I gain 1 additional proton? I plus 1 already, 1 electron. Now, total got how many? I got 9 proton, but I got 10 electron. So what happened? The whole fluorine is now going to become negative, right? Because proton positive, electron negative, I got 1 extra electron versus the number of proton. This whole thing is going to become a negatively charged species. And this is called an ion. Understand this with me, it's called an ion. Okay, so this part over here is very important for you to master before we move on to the next section. Okay, so now what happens is you must observe from the periodic table. Okay, now more annotations must observe from the periodic table that the left hand side of the periodic table over here, okay, belongs to mainly metals. Whilst on the right hand side of the periodic table over here, you realize that these over here are mainly non-metals. Okay, metals on the left hand side, non-metals on the right hand side. And what you will realize over here is that metals looks there are many metals over here. There are metals that, for example, like sodium, magnesium, calcium, chromium, manganese, iron as well. All these are metals. While non-metals, for example, they are like carbon, phosphorus, sulfur, chlorine, etc. Now, some schools, they may teach the staircase, which is this particular staircase thing over here, but I realized that most of you don't really need it. So no worries, I will not I'll talk about that. But if you know, then that's good. Okay. Yeah, okay, so metals and non-metals. Now, you realize that metals, if I were to write out a very simple electronic configuration for sodium, for example, so let's write out for a configuration for sodium, it's going to look something like 2, 8, 1. Now, what if we write out a configuration for fluorine? Okay, fluorine is 2, 7, because 9 in total, right? 9 in total. This one got 11 in total. Now, for me to get a stable configuration, my valence electron shell must have how many? 8 electrons, right? So I need to go to this configuration, 2, 8. This is the ideal configuration. Now, what can fluorine do is fluorine will gain 1 electron to form 2, 8. Whilst you can see sodium over here, 2, 8, 1, it can either change into 2, 8, 8 by gaining 7 electrons, or it can transform itself into 2, 8 by losing 1 electron. So of course, losing 1 is better than getting 7, right? Because it's very difficult to find 7 electron. So I'm going to just throw away this. Okay, sorry, throw away this electron. And this one over here is now going to obtain the stable electronic configuration. This is stable. Okay? But you see, the problem is always when we have a stable ion, right? What happens is that the number of protons no longer equal to the number of electrons. Because you see, proton got 11 now, but electron got 10 now, right? So now sodium might become positively charged. Fluorine just now, because it gained 1 electron, it becomes negatively charged. So this relationship is very important when we look at this. Okay? Metals have a few valence electrons, so they tend to form positive. Okay, so sorry, they tend to lose electron to form positive ion. Whilst non-metal, they have more valence electron than metal, so they tend to gain electron to obtain the stable electronic configuration. Okay, now I want you to fill in the blanks over here just now. We have sodium. Sodium structure is 2, 8, 1. For me to get to the ionic form, instead of now 2, 8, 1, I'm going to have 2, 8, and sodium is going to be positively charged. Okay. Just now we have fluorine. Fluorine is 2, 7. Now it's going to gain 1 electron to form 2, 8. Therefore, it is going to take a negative charge. Okay. So this is a non-metal fluorine, but this is a metal. sodium. Okay, if you're good with this, can you give me a thumbs up, please? Okay, very good. Thank you, both of you. Let's move on now, okay, to exercise number 5. Let's try this out. Exercise number 5 is a little bit challenging, but let's try this out, okay? Let's look at part A together. Now, we are asked to identify what is unique about the electronic configuration of these three. Now, if you don't know what are these three, just go back to periodic table on page number 6. Okay, you realize that helium, neon, and argon, they are all there. They are all in group 0. Okay, so these are all group 0 elements. And what is the name for it? We call them noble gas elements. Or sometimes we call it noble gases. Okay, so let's try out part A first. Sorry. Let's try out part A first. Okay, so what is unique about the electronic configuration? Very simple. You can just realize that all of the car park lots are filled. There are no more empty car park lot, right? Because 8 electrons already. This one also got 8 electrons. This one only got 2 electrons. Now, first shell maximum is 2, right? So what can we say? All their valence electronic shell are full. Okay, now there are terms that I want to explain over here, introduce to you. You must tell me it's a valence shell, the outermost shell. Okay, this one, and this one. These are all their outermost shell. They obtain a stable octet or duplet structure. Now, octet structure means 8. Duplet means 2. So helium has duplet structure because 2 electrons in the outermost shell. But neon and argon, they have octet structure, okay, because they have 8 electrons in the outermost shell. Okay, so this is the part A answer. All their valence shells are fully filled, obtaining a stable electronic structure. Okay, then in part number B, okay, we look at the unique electronic configurations affecting reactivity. Just now I say what about noble gases? Noble gases are what? Unreactive, right? So let's explain why are noble gases unreactive. Okay, first reason is because they have fully filled electronic configuration. So sorry, spelling error. Configuration. Okay, what does it do? Provide for extra stability. Okay, so 2 points to answer. Provide for extra stability. What happens then? Therefore, they are unreactive. Okay. All right. So if you're all good with this, okay, give me some time to copy this down first. Yeah, are we all good with this? I think we are okay. And let's go down to the page number 8. Okay, page number 8 is the last part I'm going to go through today. But this is very, very important. Okay, this is very, very important. Now, why is that? Why do I say that? Because when students do not understand the basic of formation of ions, it will affect their future chapters. You remember when we were talking about chemical bonding, in lower secondary, we also learn about chemical bonding, right? And we also talk about other reactions, for example, ionic equations. All of this will actually affect your future chapters. So you must be able to master this before you go on to the future chapters. Okay, let's talk about the top one first, the sodium atom first. Now, sodium atom, just now we already drew this, okay? And what happened is I want to explain the mechanism of how the sodium atom forms into an ion. Okay, how? Now, sodium atom like that, right? Just now we have already mentioned that it is not happy because this is there, and the whole level, the car park level, is very shaky because one side is lopsided, right? So what happens is, instead, I don't want anything on level 3. I'm gonna throw away this car so that I can have an empty level 3. So what can I do? Very simple. I will take this electron, I will discard it away. Okay, this is removed. And what happens next is that you realize that the whole shell, okay, we don't really draw an empty shell, right? So we will just remove the shell. And due to the loss of this electron, it is actually going to form sodium ion, right? So now I have 1, 2, 3, 4, 5, 6, 7, 8 electrons in the valence shell. And this is therefore going to be happy. All right. So this is the process of us ionizing an atom. And you realize that what is the constant thing in ions versus atoms, right? Okay, is that the proton number is the same. The number of neutrons also the same. The only thing that is different is the number of electron. Okay, electron has changed. That is the only thing has changed, right? So you don't tell me, right, because it's become positive, I do not gain an extra proton. I only lose an electron, right? I lose an electron. That's why I got more proton than electron. Not because I gain a proton. I cannot gain the proton. Why? Why is it that I cannot gain proton? Proton is inside the nucleus. It's very closely packed, tightly packed, cannot remove or cannot add one more. Right, so therefore, okay, proton and neutrons, they are the same because they are in the nucleus. Okay, so electron numbers will have changed. For me to get a positive charge, there must be more protons than electrons. Okay, so for a positive charge, must have more protons than electrons. Okay. So let's look at this table over here that beautifully summarizes what I've just said over here. Now, number of protons, we got 11 and 11. This is the atom, this is the ion. Remember, ion got positive or negative, right? We always write it on top to the power, right? Okay, so positive or negative on top. Number of electron has changed. Number of electrons from 11 goes down to 10. And that is the reason why, since I got less electrons, the number of protons have more, and that's why it's now become a positive charge. Now, I want you to now write out the electronic configuration of this and this as well. So let's write out over here. Okay, let's write out over here, shall we? So let's write out the electronic configuration. Should be quite easy for you already. Okay. Okay, so I think you're done already. Yeah, so quite fast. Now, from 1, now become 8. Right, so 1 become 8. So this means that it has gained extra stability because I have a fully filled electronic shell, and it is an ion now. So you must remember always when they are talking about ions, it must have 8 electrons in the outermost shell. Okay. So remember again, what is the term for that? It is known as the complete octet or duplet structure. Okay, so if there are 8 electrons over here, I will call this the octet structure. But if there are 2 electrons only, I will call it the duplet structure. Okay, this only applies for the valence electron shell. Okay. All right, so if I all go with this, okay, give you a while to copy anything down if you want to. And this part over here is a formation of a positive ion. Okay, positive ion. Then the next part, I will explain to you the formation of a negative ion. Okay, all good with this already, Okay. Now, negative ion, this one is a little bit challenging because instead of gaining one electron, we gain two electrons, okay? Let's illustrate this with this example. So this is for a negative ion. Now, I have an oxygen atom. Let's go back to periodic table. You can see the oxygen atom, they have 8 electrons, right? So 8 electrons, how will they arrange? I have 8 electrons. It will arrange 2, 6. Now, so if I draw out the structure, it looks something like this. And what happens is I observe that there are 2 empty carbon lots, one here and one here, 2 empty carbon lots. Now, what happens is I have 2 options. I can either gain electrons or lose electrons, right? So I can either gain 2 electrons or I can lose all the electrons here. Then I will just be left with this. Of course, I will gain electrons. It's easier for me to gain electrons, right? So I have 2 electrons. Okay, I have 2 electrons outside that I found from somewhere else. Okay, I'm going to bring 1 electron, put inside here, and another electron I'm going to put inside here. Okay, so oxygen atom like that is not happy, but once it has become an ion, it is now happy. And it is stable. Okay, so this process is known as the gaining of electron. Okay, and what happens when you gain electrons? Does the number of proton change? Number of proton does not change, right? Because only number of electron changes, but number of protons remain constant. Therefore, if I gain electrons, remember, are negative. Therefore, if I gain 2 electrons, the whole molecule over here, or the whole atom over here, will become 2 minus. Okay, so you must know the configuration, how to write this notation, 2 minus. And must put a big bracket around the atom and 2 minus. Now, I want you to make a small change over here. It's not called the oxygen ion, it's called the oxide ion. Okay, so yeah, change this to oxide ion. OXIDE. Okay, so if I'm all good with this, then I want you to take a look at this one again. Now, number of proton and number of electron. Now, number of protons, there's 8 in here and there's 8 in here. But number of electron, you realize that it has become 10, right? Because got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons over here. And there's a gain of 2 electrons, plus 2 electrons. Now, you must not confuse plus electrons but with plus charge, okay? If I plus 1 electron, the charge becomes negative by 1. I don't become positive because I gain electron. Electron is negative. Okay? So if I plus 2 electrons, then I will be 2 minus charge. Okay? So this is how I do a notation, or how I write it when I write the oxide ion configuration. Once again, I want you to take note. If I were to write the electronic configuration, 2, 6, this one is 2, 8. Okay, from 6 is not happy, 2, 8 is very happy. Okay, so this is how it actually transforms itself into an ion. So ion, remember, the guiding principle is always to obtain stable electronic configuration. Okay, so this is how it actually works. Okay, this is how a formation of a negative ion works. All right, so I hope that this has helped you to understand a little bit more about the content over here. Now, before I move on to the next part, do I have any questions? Yeah, don't worry. Just ask any questions that you have. Okay, so with that, I would like to now share a little bit on how you can best devise a game plan for you to study chemistry. Okay, so give me a while. Now, back here already. Now let's talk about how we can strategize to study for chemistry. Now you remember that for chemistry itself, right? Okay, there are 20 topics. Now for students taking pure chemistry, there are 20 topics or 22 topics to be exact. And you realize that many a times, right, you only have a very short period of time learning each topic. Okay, so let's do some math. Let's do some quick math. Now, for your whole O-level journey is a 20-month journey. So Sec 3, you have 12 months, and Sec 4, you have 8 months. 20-month journey to learn 22 topics, right? And in each topic, you will realize that it is very difficult to master it because the school is going at a very, very fast pace. So how best for you to actually study this is to actually devise yourself a study plan. And what this requires you to do is, okay, go to page, the notes, come back to your notes, go to page number 2. So this one is some of the secret tricks for you to take home if you require them. You will see on top of page 2 that I've included this part on learning outcomes. Now, learning outcomes are some students will just say, oh, very easy, don't need to take a look at this. It's very worthless. It is actually the most crucial part. Why is that so? Now, whenever you learn a topic, there might definitely be times whereby, okay, in class, you doze off a little bit, or when you do the questions, you don't really know what concept it is testing on. And the learning outcome is actually a very good consolidation. It's like a checklist for you to take note of what has been taught, what hasn't been taught, what you need to learn, and what you don't need to learn, right? And this is very useful as after each chapter has been done, for example, after today's lesson, go home and tick off which ones you have already understood. Okay. And another thing I want to share with you is basically on this quote that I want to show you. Okay. Today is the opportunity to build the tomorrow that you want. So you realize that, it's a very short time before you actually some people think that Sec 3 is a honeymoon year, right? Because, Sec 3, 1 year of rest before we can, Sec 4, you chiong for your O-level. No, that's wrong. 70% of the content that you learn in Sec 3, 70% of the content you learn in Sec 3 and Sec 4 are taught in Sec 3. And then Sec 4, you learn 30%. By June, the school finish the syllabus and you prepare to take your final national exam, your O-levels. Right, so Sec 3 is very important, okay? Don't get mistaken, you can still play, but okay, you must make sure that you get your academics on track. Let me show you what I mean by this. You see over here that in the roadmap, you see in December, okay, they will actually for you, right? Okay, some school they actually start to recap the Sec 2 topics, okay, and then they link to Sec 3s, and then they talk about some topical quiz and strengthen your foundational concept. In January to April, what happens is that the school will continue to cover new topics, things that you haven't learned before, and is sometimes very difficult for you to grasp the concept. There will also be topical quizzes to help you to master some of the concept, and there will also be practical exam, right? So in lower secondary, I think many schools don't go to the lab. But in upper secondary, you will definitely go to the lab and you will touch the laboratory equipment and do some chemical experiments as well. So you must be able to understand this very well. And you must learn new content while revising for mid-year exam for Sec 3. And there'll be a mid-year exam in May to July, remedial extra lessons, intensive preparation for end-of-year exam, chemistry practical. This one is probably like 60 to 70% of the whole year, and end-of-year exam before you get promoted to Sec 4. So why am I telling you this? Okay, I want you to devise as a plan. Since day 1, okay, you still have around 12 more days to day 1 of next year. You must be able to be prepared. Get in with your gear, arm yourselves, and let's go for it in Sec 3. Okay. For those of you in Sec 4 already, okay, some of you may be in Sec 4, then it is even more tight, right? So you must be able to prepare yourself well. Now, for us ourselves, right, I've been teaching for quite a while already, but I'm just going to announce this. There's going to be a Sec 3 chemistry structure program, which is our signature tuition classes in 2023 as well. Okay, so just give me a moment. Let me go through this. We have structure program to design this curriculum to actually bring you through your O-levels with ease. right? So we offer hybrid lessons. We have Zoom lessons like now, and we have classroom lessons at Jurong East as well. So the academic team is actually made up of ex-MOE teachers as well as full-time tutors. We have Miss Joanne Wong, which is helming the A-level program, and myself, who are helming the O-level program as well. So for us, we are a very dynamic team. We are very more than experienced to actually tell you and guide you the correct methods to actually learn to score well in the O-level exam. Now, what sets us apart from other centers is that our resources. So you realize that the resource that we provide you today is actually top-notch, and we design it specifically, not just to learn, but to revise as well. So we always provide, like, for example, different small boxes that you fill in today. So when you're doing revision, just go back, look at the small boxes. You will actually be able to remind yourself on the important concept for the exam. We also have a topical guidebooks, which is to issue to every student, whereby we look at the different work examples, the concepts and questions to stretch their learnings as well. And these workbooks are only available for in-house students. And for those students who need a little bit more tender loving care, we do have customized individual learning needs for everyone. We actually help to recognize that each students have their varying strength, and we recognize this. So we help them individually by providing customized worksheets, customized guidance, consultations with our tutors, and close their existing learning gap and target their weak areas. So you can focus on your strong areas, but at the same time, help yourself by securing the extra marks in the weak areas as well. So if you decide that, we are a good fit for you, what is the Edgewise experience that you actually have is this 4-prong approach, which is on concept mastery, customized guidance, targeted curriculum, and flexible learning. So concept mastery, once again, we explain things until it's crystal clear. You will realize that in school, you don't really learn things until so deep, right? Because they simply don't have enough time. But in our classes, we actually explain straight to the point by using analogies, for example, the car park example, and to actually guide you using the concept-based method that has been effective, tried and tested for many, many batches of students. Our weekly lessons are curated by ex-MOE teachers, and they are targeted curriculum to ensure that yourself receive timely, targeted, focused practices before your major assessment as well. So there are some students who ask, is it okay if today I don't feel so well, I want to go online instead of attending in the center? Of course, you can actually opt for Zoom lessons and on-site lessons, attend hybrid lessons as well. So the in-class experience, what you will get in class, we focus on during the class and after the class experience. During the lesson itself, we'll share with you the tips and tricks to ace every single chapter, and there'll be a weekly 2-hour-long chemistry class conducted by your tutor and free personalized consultation before and after. So don't worry about your schoolwork. If you don't know how to do, bring it to us. We will explain it. We will teach you how to guide you to the questions, to the answers step by step. And after the lessons, we also have a support study group chat, with the teaching team to help you to clarify and receive additional chemistry help out of classes as well. We also have our LearnEdge portal, which I'm very excited to announce. This is actually our all-in-one student learning platform, which we have taken pains to design. This is very, very state-of-the-art. You can actually find all your lesson recordings or short concept videos. For example, I'm learning about acid bases now, and I want to go in and learn a little bit more during my free time. I can just go into the website, I can click on the videos, and I can watch it as well. I can download the notes and watch it alongside it as well. So it's a 24/7 learning experience that all of you may actually be able to learn more. We have tried and tested this with the batch of students this year as well. It has been very effective. So you can see how that we have a lot of reviews, how the tutors are very patient. The break was we give for students to actually rest during mid-lessons and able to simplify the concept very well and explaining each questions until it is very crystal clear for every student. So what are our customized learning plans if you feel that you need some extra help for chemistry? We are actually offering our chemistry tuitions classes, which is $70 per lesson and $80 per lesson. So if you require the additional lesson replay, all this, you can sign up for our premium plan as well. But for a limited time only, if you sign up for our regular plan, we will give you a free upgrade to the premium lessons for before 20th December if you sign up. So class schedule is as shown. If you are interested, you can actually submit the form, and then you can see the classes that you can indicate over there as well. Okay, so if you sign up today, what you will get is your weekly 2-hour lessons, free upgrade to the premium plan, okay, which is worth $100, VIP access to the learning platform and app as well, valued at $1,002. Simply sign up, we will waive the registration fee of $50 for you. We will provide exam topical guide and revision summaries valued at $480, and priority class selections and 15% off if you pay by term as well. Okay, so receive a $50 holiday program vouchers if you sign up for 3 term and more. So this is valued at $50. So total value that you sign up today is more than $3,260 in value. And how much does this cost? Is only $70 per lesson. So if you're interested in this, okay, you can actually scan the QR code to actually do the pre-registration. And for students who are still a little bit hesitant about this, you can actually scan the QR code, you submit it. We will provide you with more information if you require time to discuss as well. No worries. Okay. Right. So this is the structured program itself. And we actually provide all these features in the program itself. Okay. So if you are interested, you can scan the QR code to do the pre-registration form. Okay, so thank you so much for staying all the way until this point of time, and I really appreciate your attendance. If the lesson is good, can you please help us to fill out a feedback form over here? Now, once you complete the feedback form, there will actually be a giveaway, a free giveaway, showing giveaway for you once you completed the feedback form as well. Okay, I hope that the lesson has helped you a lot for especially those students who are going to select chemistry as one of their pure subjects next year. And I wish you all the best. If you have any questions or if you require any assistance at all, okay, please let us know. Okay, you can text me privately as well to ask the questions as well. Okay, so help us to fill out the feedback form, okay, and we'll actually organize a lot more sessions in future like this for you as well, free of charge. Okay, if you haven't joined our Telegram group chat, okay, you can just scan the QR code to join us. There are no obligations to it. Just join the Telegram group chat. You can ask questions inside there. You can receive help from there. You can just take a look at all the free cheat sheets that we actually send inside there. Right. So there's an Instagram QR code over here. You can actually scan it. Okay, scan the Instagram QR code. Give us a follow so that you are able to stay in touch for any future events that we organize. Okay, is that okay, everybody? Now, once you're done with this, okay, just fill out the feedback form for us, and we will actually, for students who are interested in our tuition programs, then you can just let us know, and we will reach out to you accordingly.